Good evening. This is Shane Artman, and working with Sterling Wright, we have put together this presentation on packages. This week, we began talking about packages, and first I wanted to understand what a package was, and so I thought I'd go into an explanation. A package, to me, is simply an organization of code that we can repurpose multiple times. It's a way to organize the code similar, in what I've seen, similar to that of other programming languages like Java, where you might create the interfaces first, and then that would help to be certain that the implementation of those interfaces are what the developer anticipated. So we're going to go through some examples here, but I've pointed out a couple of the highlights of a package. Grouping functions and procedures into a library, sharing those variables, types and components into itself, into its own functions that exist within it, as well as PL SQL blocks outside. It is owned by the user schema where it was created, and this helps to divide the declaration from implementation so that you can kind of keep things containerized, if you will. Package architecture includes package specification as well as the package body. So you'd separately declare the package specification, which includes variables that would be leveraged, data types, functions, procedures, and so forth. You would be able to call these published functions and procedures for use in within the package body or outside into other PL SQL blocks as well. The package body defines what the package implementation of the specification was, and so here you would actually define what we're implementing. Here you'll see an example of an overloaded package. The reason I did this was it can get fairly complex, but the concept is that you have a function that essentially does the same thing, but you want to make sure that you implement that function in a manner that meets the need. So if someone passed you, you wanted to add two values together, but someone passed you two numbers versus two, in this case varchar 2 variables, then we can overload the function name. In this case, I have add. You can see here in this section. So we have a package called package test. We're overloading the function add. The first implementation will have two numbers, and the second implementation will have two string values, and then we're obviously returning either a number or a string value. The body example of the overload procedure here with the specifically overloaded functions for add are leveraging the exact same variable names. I think that's important to point out. When I tried to complete this initially, I intentionally tried to separate the variable names, and I had a lot of problems. The error basically said that you're not implementing the necessary function as was defined in the specification within the body, and so I needed to go make sure that they were identical. So once I added those variables to be the same name as what was in the specification, that cleared up my problem. And so you can see this function is simply adding two numbers together, and it's returning the value of those two numbers. And then in the string, we're returning a string. I'm actually returning a string called returning, which I cannot spell, obviously, returning. And I'm passing those variables that I received back aggregated together. And then here is a simple anonymous block that I put together to leverage the test. And so you'll see that we're going to overload a number, and then this one we're overloading a string. In this one we're passing it 2 and 2, and this one we're passing it a string value of 1 and 2. And then our results. You can see that the results printed out, hey, our test for the overloaded number added this function in the package test, and we passed it 2 and 2, and we returned a result of 4. And here we passed it 1 and 2 as a string value, and we returned the result of returning 1 and 2. All right, well, hopefully this was helpful, and have a good week.